All right, I think it looks like a lot of people have gotten in, so we'll go ahead and get started. Thanks, first of all, thanks for joining us for our webinar today on data mesh architecture and the importance of a data-centric security approach. First, just going over a few logistics. We'll be handling any questions during the webinar through the Zoom webinar question interface, and you should be able to type out any questions, and we'll either try to answer them in the course of the webinar, or we'll answer them at the end during the Q&A section. You should be able to see the button for asking any questions at the bottom of the Zoom webinar application. Also, this webinar will be recorded and will be available online as soon as we have finished processing the recording. So everyone who registered or attended this webinar will receive a notification at that time with a link to the recording of the webinar. You can definitely view this yourselves and share it with anyone that you think would find it useful. So with that, we'll go ahead and get started. Just a brief overview of the agenda today. We'll introduce myself and Rajan, who's joining me today to talk about the data mesh topic. I'll hand it over to Rajan, and he will give an overview of data mesh and what exactly that is, what are some of the implications. Then I will go into a little bit of what NextLab's Zero Trust Data-Centric security solution is and our security suite. And then we'll switch back and talk about a few examples of data mesh, and then we'll open it up for Q&A. So again, please feel free to ask questions at any time during the webinar, and we may also answer them as we're going as well. So to give a brief introduction, so my name is Tony Burning. I'm a senior product manager here at NextLabs. And today I'm very pleased to be joined by Rajan Rarane. And I'll hand it over now, Rajan, to you to introduce yourself.
Yeah, thanks, Tony. So again, you can call me Raj. I am a data consultant, mostly focusing on the data solutions, over decades of experience on the data. And I'm certified on the cloud, such as Azure and AWS. So that's me.
Yep, yeah, and thanks for joining. So so Raj, I'll hand it over to you. Are you ready to share
Yeah,
your screen? Okay, great.
yep, yep. Okay. So, is everyone able to hear my voice properly?
Yep,
You're
I
good?
can hear you great.
Okay, okay.
And I can see yours.
Okay, thank you. So again, before I start talking about data mesh, right, let's dive into the background. Okay, data mesh is mostly related with the data analytics solutions, and it's not new. Okay, organizations have always needed to analyze the business performance and have done so by using computers since their introduction. Around 1980s, that's where the era of data warehousing solution. Okay, it started building data warehouse using the database specifically for decision support. These data warehousing solutions served as organizations well for a long time. However, as business changes and generates more diverse data, the data warehousing solution that uses this database might not always the best solution. So in early 2000, okay, we had a term of big data and DWH solution. Business adopted new solution that allow analysis for large volume of diverse data that would generate with a great velocity. Now, this include the architecture customization like data lake and scale out solutions that analyze large quantity of data. Now, coming to this area, recent years, right? We are talking about 2020, 11 onwards, okay, where the architecture was improvised to DWH, big data, cloud computing. Many organizations successfully use modern architecture and analytical platforms to combine the data warehousing technologies with recent cloud and big data platform. However, some organizations encounter issues when deploying the analytical solutions that uses the analytical platform. So these solutions are commonly still implemented as a monolithic solutions. So if it's a single or small team, right, they're easy to adopt and deploy. But it becomes tricky when it comes with a larger organization. And this bottleneck causes a huge backlog, which results in issues, data issues, or analytical issues. Now, what are the unsung challenges of each generation from 1980 2000, okay, to the recent years. Every generation has its own improvisation on the architecture. So let's talk about the first generation. Now here people has developed the jobs, preferably ETL jobs or API jobs, tables and report that only few experts can understand and fix. They don't use the modern methods, right? That recently we are talking about CI/CD, right? So also the way they organize data doesn't work in handling all the data types. So let's take an example. Okay, you have a company, it's a small team. Okay, now this team knows how to manage the data jobs and reports. They do things in the same way for a long time without using new technique. So when a company needs to handle more data types of data, it becomes difficult because their old way of organizing data isn't flexible enough. So that has resulted in customizing the architecture and evolution of second generation. Now here we have seen the architecture changes with the concept of data lake, right, or big data. Now here as well, whenever the architecture was developed, the data lake was mess. Data quality gets worse. Uh, Sorry. Okay, sorry. Yeah. Data quality gets worse, and it's hard to trust and find the data you need. The way the data was moved around different system was complicated. This make it tough to know where the data comes from and how it is connected to the other pieces of data. Also, without planning well in advance, different types of data, when mixed together, it becomes hard to understand. Now, I'll give you an example for the second generation. Assume that you are in a library, right, where your books are scattered everywhere. Now, only few librarians knows where to find them. The more books come in, they get mixed up, and nobody knows which books are reliable or which where they belong. So it becomes a headache for anyone to trying to find a specific book. Now, this resulted in evolution of third generation. Now, here also you'll find the data lake, and still it is challenging. This impacts the accuracy of data, making it less dependable. It still relies heavily on the specialized team, okay, who has knowledge on it, obtaining the necessary data for analysis or machine learning continues to be time consuming. Moreover, even when the data is acquired, it may not reflect the reality or real world situation. So let's take an example on this as well. Okay, okay, for the kitchen. So imagine you are in kitchen, okay, where ingredients are scattered and only few chefs knows where everything is located. Even when someone finally gets the ingredients they need, okay, but it could be possible that they are expired, or they are, that is not suitable for the recipe that they are preparing. So having this scattered issues still a mess still mess while building the architecture. Now, this is the architecture of all generation. I'll just take a minute where you guys can. So on the left, you have the first generation where you're going with the source to reporting. Then there is an improvisation of data lake, and then and in third generation, it's a fusion of data warehouse, data repository integration, and data lake. I'll take a moment, and then I'll jump into the next slide. So basically, what we are saying here is, so the evolution of each generation, okay, it has adopted some architecture patterns. Not all generations are us. Okay, every generation has its own merits, and people has improvised based on the data needs. Okay, the goal is to create a more efficient, reliable, and scalable data environment that enables better decision making capability. Now, because of that, right, because of the issues, unsung challenges, it resulted into the fourth generation. Now we are talking about data mesh. Uh, First, dive in. What is data mesh by definition? Data mesh is a modern approach to organize and manage data within the organization. Instead of having one centralized data architecture, data mesh distributes data across different domains, and each domain is responsible for managing its own data, including modeling, storage, governance. The architecture employs data standards and clear data governance principles to ensure reliability, security, and effective use case of data across the organization. This approach is akin to how microservices revolutionize the monolithic applications by breaking them into smaller and independent units. Now, this is a definition. Now, I'll explain you with an example that might give you more clarity. Okay, take an example. You are in a big party, okay, with lots of different foods. Okay, so in the past, you might have kept all the food in one giant kitchen, but that made it hard for everyone to find it what they need, and sometimes the food got mixed up or even bad. Now, with the data mesh approach, if I want to link it, okay, it's like having multiple kitchens spread out across the party venue. Each kitchen is responsible for specific type of food. For example, there is a pizza kitchen, there is a dessert kitchen, there is a drink kitchen. So each kitchen knows exactly what and who is in charge and who take care of its own food. Similarly, the company using data mesh, instead of having one big data system, the data is divided into different kitchens, which we call here as the domains. Each domain take care of its own data, like sales data, customer data. So they use clear rules and standards to make sure the data is reliable and safe. So it's just like having separate kitchen at a party makes things easier to manage and find the data in a better way. So data mesh approach makes it easier for companies to handle and use the data effectively. Okay. Now, data mesh is built in some core components like this. These are the four standard core components. Let's dive into each of them. First is domain-driven decentralized data ownership. Okay, what exactly this means? In data mesh architecture, data ownership is distributed across various domains, okay, or business units within each organization. Each domain is responsible for its own data, including data modeling and storage and governance. Okay, sorry. So let's take an example of this core component. In a retail company, we might have separate domains such as sales, inventory, and customer. Okay, so each domain is accountable for maintaining the quality and integrity of data. Now, second is self-serve data infrastructure. Data mesh architecture emphasizes providing self-service data infrastructure to enable easy access to data for user across the organization. This infrastructure includes tools and platforms that allows the user to discover, access, and analyze the data independently. Now, with an example, in a healthcare organization, okay, you might implement a data catalog that allows researchers to research and access the various data of healthcare, okay, for analysis without relying on the IT support. Now, third is data as a product. Now, in this approach, data is treated as a product that is produced and consumed by different parts of organization. Just like as a product, data should have clear documentation, quality standards, and user support. For instance, consider a financial services company where risk analysis team produces a data set containing credit risk matrices. This data is then consumed by other teams, such as marketing or product development, to make informed decisions. Okay. The last one, federated computational governance, which is also called as federated data governance. Now, governance is a big piece when we are talking about architecture, right? So, data mesh architecture employs the federated data governance, where each domain has its own governance practices tailored to its specific needs and requirements. However, every overarching governance principles and standard that ensure the consistency and compliance across each domain. So, with an example, suppose a multinational corporations have different subsidiaries with their own data governance policies, but they all adhere to overarching corporate data governance standards related to data security and privacy. Okay. Now we have seen what is data mesh at this point. Let's see what isn't. Okay, now there is a confusion of between the architecture, right? Because the terms become common, but it needs to be drilled down to get more clarity. Now, let's talk about the centralized data control. Okay, in a simple word, it means that instead of one group having all the control over the data, the in data mesh, the ownership is spread among different teams. However, everyone still follows the same rules and standards for how data is handled. So, for an example, imagine you have a big puzzle. Instead of one person holding all pieces, okay, each person gets some pieces to manage, but they still need to make sure their piece fits with everyone else to complete the puzzle correctly. Okay. The second one, elimination of centralized function. Now, it means that while some centralized functions like security rules, standards, or providing tools may still exist, they change how they work. Okay, instead of controlling everything from the center, they focus more on helping specific team with their needs. For instance, imagine a school where teacher decides a rule for their classroom, but principal helps them and setting up the school rules, providing the resources like textbook. Similarly, in a company, teams might handle their own tasks, but still there are guidelines and tools that provide by the central department to support them. Third, silos and fragmentation. Now, this is a major piece where like everyone wherever I talked about data mesh, right? Everyone says, okay, since data mesh is on the based on the different domains, then definitely it would be silos and fragmentation, right? So there is some clarity on it. So whenever we are talking about data mesh, right, it means that even though each group is responsible for their own data, okay, the goal is to make sure that all data can work together easily. It's like having different parts of the big city with their own neighborhood, but they are well connected through roads and bridges, allowing people to move freely between them. Similarly, in a company, different teams might manage their own data, but the system is to set up so they can easily share between them, collaborate with each other. One size fits all approach. It means that it isn't one way to do or to fix all the solution. Instead, how it's done can change depending on what company needs, how big it is, okay, what kind of business it's in. Uh, take an example, a cooking meal, right? There are many recipes. You can adjust them based on what ingredients you have or what flavors you like. Similarly, when setting up the system in a company, you have a standard architecture, but you tailor it based on your situation and goals. Finally, the solely technological solution. Now, in the simple terms, it means that it's not only about of using new tools, okay, but also about changing how people think and work together to use the data effectively. Imagine a sports team, right? They don't need just a new equipment. They also need to train and work together as a team so that they can use it well. Similarly, in a company, it's not about having or getting the data onboarded or data tools onboarded, right? It's also about encouraging everyone to use the data in their decisions and collaborate to make the decisions better. Now, this is an high-level architecture of the data mesh. Suppose you have two domains. Domain one could be your sales, domain two could be your marketing. So you have a different layer architecture. Okay, so from the sources, you store the data into the operational data plane. Okay, that is tied with your sources, domain sources. But when you're trying to derive the data into the analytical plane, okay, still there is a connection between the each data product. So remember we discussed about the silos and fragmentation, right? So the orange dotted line says the same thing. Okay, you still have that connectivity between each data product so that the other team can collaborate and share. Now, across this architecture, you have the federated governance, okay, where you can define the policy compliance that is adhere with the organization policies. You can use a self-service platform for data cataloging or for the security reasons or for monitoring your architecture data pipeline. Sorry, I'll just take a moment so that you guys can look, and then I'll jump into the next slide. Okay. Now, what's the benefit of having a data architecture, data mesh architecture? Okay, less bottleneck. Ideally, when we discuss about this, when you have a central data team, right, you have a complex data issues that needs to be fixed. Okay, you need to find the data insights. You have your data is scattered, so you have to spend time in looking into the data issue that slows down everything. Using the data mesh architecture, because the architecture itself is spread out, it has a less pressure on the central team. Okay, they can focus on the insights without getting bogged down by technical problems. Second is faster data processing. Ideally, in a central architecture, you have all data in one place. Definitely, it will slow down the processing. Having data mesh within architecture, you are splitting the data task among the different areas, making it easier for your data systems to handle the load. Take an example of providing API to reduce the individual data requests, speeding up the processing further. The data democratization. Okay, it's hard for different people in your organization to access and understand the data they need. Now, with data mesh, it becomes simpler for everyone from developers to business users to find and use the data they require. This means the insights come faster, benefiting the whole organization. Compliance and security. Keeping track of who has access to the data and ensuring compliance regulation on the complete architecture at the enterprise level is tough. Okay, so with data mesh, each domain has its own access control, making governance stronger. This ensure the compliance with regulation and helps auditor to understand the data usage easily. Cost efficiency. Now, traditional data system can be expensive to maintain and scale. With data mesh, often uses the cloud services, which are flexible and cost effective. You can scale up the resources as needed, and you can pay for what you're using, saving money for the long run. Interoperability. Now, data structure vary across from different teams, so it is hard to connect and use them together. Benefit of data mesh architecture, they are consistent. Okay, and you can follow the consistent rules for structuring the data across the domain. This make it easy for different parts of your organization to share and use data effectively. um, so this is me, and I would like to pass to Tony for the next lab, for the other slides.
Thanks, Raj. Go ahead and take the screen back.
Yeah, yeah.
All right. So yeah, thanks again. Thanks for the background, the explanation of data mesh. So what I will like to go through now is how NextLab solution can actually help organizations that are looking to move to a data mesh architecture, and how specifically our data-centric security approach is a good fit for moving towards that architecture. So it as a little bit of background on Next Labs, the core challenge that Next Labs helps our customers address is how to balance the need to share with the need to protect. So organizations need to share both internally and externally, while making sure that that data remains protected. Um, so part of addressing the need to share is really what the data mesh architecture helps with and is about. It decentralizes a lot of the data so that it's easier to share within different groups as in the way that each group finds most appropriate. And that allows organizations to be more agile, improve their time to market, and then make the most of business opportunities without waiting for a large centralized or process to be done. However, even though it needs to be shared, that increases the needs for protecting that data. So that the data still needs to be protected at all times. Um, Sensitive data needs to be secured to protect both intellectual property and trade secrets, as well as the need to remain compliant with data privacy regulations or other data regulations, depending on the different jurisdiction or geography where the organization is operating. So with a decentralized data approach, it's more important to really have a good approach to maintaining the security of your data wherever it is, and that's really where Next Labs comes in. So our solution for balancing the need to share and the need to protect is protecting data at different stages of the life cycle. So where it's created, when it's being shared, when it's being used, when it's on the move, protecting it wherever it is. And so that could be in different enterprise applications, content management systems, and SaaS solutions, or even unstructured data like files. Um, However, uh, you enforce consistent data policies and access policies using our centralized policy platform. So our platform integrates with a number of different systems to allow you to uh, enforce those policies consistently, no matter where and when the data is being accessed. So our native integrations within our applications and the content management systems and the different platforms allow our attribute-based policies to be evaluated and enforced dynamically at the time that the data is accessed. And also, the centralized platform does provide automated audit and compliance reporting to reduce the time and effort required. And so this allows Next Labs to help organizations protect data throughout its entire life cycle. Again, from when it's created, when it's used, when it's at rest, and when it's on the move. And this is done without restricting an organization's ability to share that data quickly and effectively. Um, So our solutions help organizations implement a zero trust architecture, which is as with a data mesh architecture is adopting a lot of these. Well, securing a data mesh architecture requires adopting and implementing a lot of these zero trust principles. Um, this is because there is no castle and moat that you can defend, no perimeter that you can secure. And instead, you need to protect the data wherever it is without there being clear, defensible boundaries. So this is zero trust is being adopted more and more, both in commercial and public sectors. The public sector is being guided by U.S. federal mandates, but then a lot of the commercial and private sectors are adopting it as a best practices as well. Um, but as network perimeters become less defined, and with data mesh architectures, you don't have a single consolidated database or data store to defend. You need to be focusing on the data that needs to be protected and protecting it wherever it is. Five main principles, just to go over them quickly. All resources are accessed in a secure manner, regardless of where they're located and where they're being accessed from. You only grant access on a need-to-know basis, which is strictly enforced. The third, which gives its name to zero trust architecture, is you never trust, always verify. So even if someone has gained access to secure systems or networks, you still validate their authorization and to access the data that they're requesting. You inspect and log all traffic. So this is what's so important to detect threats with a data mesh architecture, is that you need to be logging that traffic, that access from wherever it's being located in the different domains and different areas, so that you have a centralized database, both for audit purposes, as well as to identify any potential threats that where someone might be attacking multiple areas of the organization. And then finally, the need to design the network from the inside out to make sure that security is designed from the very beginning. Again, this means that integration of security needs to be as Raj mentioned, like part of each part of network, even in the data mesh architecture, where different domains all need to integrate security. And what NextLab says is it allows you to protect that with consistent data access rules. So a little bit of background on Next Labs. We are a leading provider of zero trust access management and data protection software. and we help customers protect their data anywhere and everywhere. I'm not going to go through all of the companies on this sheet, but we have a number of customers who've worked with us for years, as well as a number of strategic partners that are both go-to-market partnerships as well as OEM partnerships. Um, we also work with the NIST, the National Institute of Standards and Technology, and are part of their National Cybersecurity Excellence Partnership Program. We have over 200 employees worldwide with offices in the US, Europe, and Asia. And we have a very strong technology patent portfolio with over 80 granted and more than 30 still pending. Our suite consists of four main products, and I'll go into each of those in a bit. Actually, let me go ahead and jump to the next slide. So the four main components of our data security suite. First is Cloud AZ, and this is our unified policy management platform that provides a centralized policy enforcement with our dynamic authorization policy engine. This is the policy platform that allows our data security policies to be enforced with all of our other products, and it allows those data policies to be defined and enforced consistently wherever the data needs to be protected. SkyDRM is our enterprise digital rights management product that provides a persistent protection of files and other unstructured data wherever they are shared and wherever they are stored. Our application enforcers provide externalized authorization management and protect the application data, simplifying the process of role management. With the application enforcers, data protection policies are enforced at the application layer, and that is true for all of the different applications that we have integrations with, and in application enforcers that we have integrations with. And then finally, Data Access Enforcer, or DAE, provides the evaluation enforcement of data access policies at the data access layer, protecting critical data that's stored within databases, regardless of the application that is accessing that data. Again, all of these enforcers, SkyDRM, application enforcers, and data access enforcer are using the policies defined within Cloud AZ to provide consistent data access policy enforcement in all parts of an organization and within all applications, all networks, etc. Our patents, which I mentioned before, again, we have a very strong patent portfolio, and we do believe that gives us a strong advantage in the market. But just letting you know, like we have a lot of them are in the area of zero trust, data-centric enforcement, dynamic authorization, and especially around our real-time policy engine. So that is a very, very strong part of our data security suite. Some of our competitive advantages and technology edge, and this is where our patents lead into this. So we have been in the space of dynamic authorization and zero trust since the very beginning. Again, with a number of the patents speaking to our strength in that area. Our policy engine is very high performing and very scalable. So we have a very mature battle-tested policy engine that we process greater than 10 billion authorization requests per year across our different customers. Deep industry and subject matter expertise. Again, we've been in this space for over a decade with hands-on expertise, helping many large organizations that have very complex data security needs. And so, that's again something that we leverage in the development of our products and the advancement of our products. Speaking of which, there's a few of the main areas where NextLabs helps our customers. To go over them briefly, modernization projects, providing centralized authorization for both legacy and new applications without having any gaps in that data protection. In the areas of compliance and segregation of duties, ensure there's no violations of regulations. And again, even with a distributed data mesh architecture, making sure there's no compliance issues or regulatory issues by having a consistent application of data security policies. Um, Not as relevant to data mesh specifically, but a big another area where we are strong is in for customers that are doing ERP consolidation projects, and that's because our products allow them to logically segregate data within a single database. Again, not the focus of a data mesh, but again, a large area that we are strong in. Um, Similarly, in mergers and acquisition, allowing logical segregation even with shared systems. Um, Cybersecurity, there's a lot of organizations that are adopting best practices and especially following the guidelines provided by NIST that will implement us to improve their cybersecurity postures. Um, And then finally, in the areas of trade secrets, so use NetSlabs is used to protect the trade secrets and implement a least privilege access, need to know data access policies, regardless of where the data is being accessed within an organization. And all of this, and our products also help automate the application of all of these policies and update data security. Um, uh, Policies and access rights for all users. So our main approach, just summarizing, is knowing your data and your identity. And so this is especially true for distributed architectures like a data mesh architecture, where knowing where data is kept and needs to be protected, and what type of data is kept in different spots, so that you can protect it. And then protecting that data at the source, so where it's being stored, regardless of where that is, when it's being used. So that could be when moving between different domains or different organizations, but making sure that that data is protected in transit and at rest, whenever it's used within applications as well. Again, whether it's originating within those applications or that application is using data that is coming from someplace else. Automating and orchestrating those policies to make sure that there's consistent policies applied throughout the different domains of distributed data architecture, and then finally having the visibility and analytics to bring that all together and get a holistic view of the data access for critical data and protected data. So when I mentioned how we have attribute-driven, policy engine, here's an example of just what that means. So NetSub's policies are defined in terms of attributes of the the subject, the person who is accessing it, or the program that's accessing it, the environment, so where they're accessing it from, when they're accessing it from, what networks, and then also the resource itself. So what is the type of data, whether it has restrictions or data classification. Um, and then the policy will then allow you to perform certain actions based on how those attributes are evaluated and what those values of the attributes are. So as an example, you may only allow customer service representatives to have read-only access on sales data, but only for customers within their own region, and only if they're accessing it from during their defined work hours and from their defined office locations. So this is an example of how you can protect data even when valid credentials have been compromised, because if the NextLab's policy engine detects that it's being accessed from outside of an employee's known office location or outside of their normal working hours, it can prevent access as a potential um, compromised credentials. So that's a brief overview of NextLabs. Obviously, we can provide more information, more detailed information, and more specific information for any specific use case upon request. But now I'm going to hand it back over to Raj to go over a couple case studies. Um,
Okay. Thanks, Tony. Okay, let me share the screen.
mhm.
Okay. So yeah, Tony, I think that was really helpful and insightful, because when we are discussing about the architecture, right? Any architecture doesn't go well if you have a strong data security in place. So the use cases, the details that you have mentioned, that definitely tie up with the enterprise architecture. So if I go with the governance policy, right, having an architecture and the top of federated governance where yeah, where the solution of next lab can be more useful and more strong on having a good eye on the complete architecture. Okay. So let's talk about the case studies, right? So data mesh is quite new, but it has been adopted by many organizations, and people have seen the real benefit. Okay, uh, I've added the two couple use cases which has been published. Okay, but definitely there are many customers in the market who has been adopted this architecture. Now with Intuit, right, it's a financial software company. So the issue they had is there are a lot of systems and a lot of data in silos, and they want to improve the data accessibility. Now, the implementation approach they did is they brought all your product teams, okay, together, and they tried to sort the issues of data silos, okay, and allowing the data product team to manage the data. So they built an architecture along with the product team and define the domains. What was the outcome of it? They can access and utilize the data more effectively, resulting in improved product development and faster innovation cycles. ThoughtWorks. Now, ThoughtWorks has completely changed the internal architecture. They have so the architecture was driven by microservices, APIs, ETLs. Okay, so they went with the standard framework of data mesh. Okay, they focused on the core components. They implemented domain-specific data platform, those which are built with the microservices, define the domain and create that layer architecture, derive the self-service capability and federated governance. That's where your security comes in place. That's where next lab security aspects also comes in place to empower the data domains. What was the outcome of this? Team being like after it was shift from your traditional architecture to the data mesh architecture, it has helped the teams to manage the data more effectively, leading to better insights, faster decision making, and improved the collaboration across the departments. So these are the two use cases, but as I said, right, you might find many customers in the market who has been implemented the data mesh, but these are the standard two use case which has published. Okay, so Tony, it's over to you.
All right.
Yeah.
And thanks. And now we'll open up for any questions. Again, just use the you can use the Q&A interface within Zoom webinars. First question is about how do you deal um, with organizations that have different types of technologies, like different enterprise systems in place across their different um, offices. So I'm assuming this is more about, let's say you have both you're using both Oracle, SAP, Microsoft. So one of the advantages that NextLabs provides with its architecture, with its data security suite, is that we do have integrations with all these different enterprise platforms. So you can have your policies defined within Cloud AZ, and then have enforcers that allow those policies to be enforced at Oracle databases, within SAP, within SAP HANA database. It could be an Azure SQL Server database. The beauty of having NextLab's centralized policy platform is that we do have all these different integrations that allow you to enforce those same policies consistently across different technologies. But our yeah, it is very important to not have a differentiation between the policies that apply dependent on depending on the technology that is being used, because that could open up some holes. Um, so I'll pause here. Let's see if there's any other questions. Just mentioning again that a recording of this webinar will be posted afterwards, and everyone will get an email with a link to that recording. And again, share this with whoever might find the information useful. While we're waiting for any questions, Raj, do you have any other final thoughts on that maybe we didn't touch on during the presentation?
No, I think at this level, Tony, we are good because today there are a lot of architecture in market, right? Like, sorry, we are industry is moving to the cloud. We're talking about AI, right? We need a robust architecture. We need a robust data security. So understanding which architecture is right for their teams is also useful. So I would say that having such sessions would at least help the team to or people to understand, okay, how the architecture differs from the different architecture, what is the evolution, and then they can adopt in their organization in terms of better fitment for the solution implementation.
Yep. Okay. Oh, and one more question, a clarification question, is how do you combine like having a decentralized data architecture with having like a centralized logging? And so I do want to clarify on that point and centralized policies. Um,
Yeah.
so even though
Okay.
the data is uh, distributed and policies are being enforced at the different spots within a network within the distributed network, it is important to still have those policies be defined and the data access policies be defined centrally and have those be logged and having a centralized audit trail. I mean, this is both true for compliance purposes for organizations that do have compliance requirements or working or in highly regulated industries, but then also just as a general security measure as well to have a view of make sure there's no weak spots or gaps that any malicious actors could potentially um, access or, just not leaving any gaps for employees to accidentally potentially expose data that shouldn't be exposed. So it is important to have those policies be applied consistently across um, a different organization or even a distributed architecture like data meshes. So with that, I don't see any other open questions. Again, you can follow up with both me at Next Labs or with Raj with any follow up questions. Just let us know if you do have any questions, and we'll get back to you with any further details that you need. Again, thanks for joining us today. Appreciate the time, and we'll be sending out a link to the video as soon as we have that processed and online. So thanks again. Thanks again, Raj, for joining me today.
Yeah.
Really appreciate
Thanks, Tony.
it. Mhm. Great.
Thank you, Tony. Yeah.